Okay, so let's resume where we left off. Okay, firstly, for your Na2SO4, okay, your anode reaction will be sulfate versus hydroxide, to which hydroxide obviously takes priority, right? So you have 4 OH minus to give you 2 H2O plus O2 plus 4 electron, 对吗? Okay, then we carry on. On the other side, you have Na plus versus H plus. Who win? Hydrogen, right? Less reactive will win, So you have 2H plus here, plus 2 electron, give you H2. No problem. Are we okay? Then in the next one, I have concentrated sulfate versus OH minus. Concentrated means by right, the anion should win, correct? Unfortunately, we are using a stable anion. So even if it's very, very concentrated, he still doesn't win. Which means, again, I have hydroxide. Okay, I say again, sulfate never takes priority on. He's never preferentially discharged. Are we clear? Then the other side, I have aluminium, Al3 plus versus H plus. Again, hydrogen will win. So it's exactly the same as example number 2. Okay, no difference, because hydrogen still wins here and sulfate will never be discharged. Correct? Correct? Okay, we have one last example. Molten, okay, concentrated means what? Concentrated means I have a lot of sulfate ions and a lot of aluminium ions. But I still have H plus and OH minus, which will still take priority. Concentrated doesn't mean no water. Concentrated means very little water. Okay, you know Milo dinosaur? That's concentrated as fuck. Okay? Versus like a typical Milo is a little bit more diluted because got a lot of water. Can? Okay, so I have molten MgBr2. Molten makes the question very easy because I just have this fella and I just have this fella. There is no H plus, there is no OH minus to deal with. Correct? So when your reaction goes like this, okay, your oxidation will be who? Tejra? Br, 2Br, arrow, Br2 plus 2 electron. Like that only. Where your minus charge, bro? It's bromide ions that are reacting. Correct? Kaylee, agreed? Okay, your Mg is not on this side, your Mg is the other side. Okay? For your oxidation, you will choose your anions. Because if you are negative, then you want to become positive. If you're positive already, you become more positive. Makes no sense. Right? Okay, what about the cation reaction? Okay, you have Mg2 plus. You will gain the 2 electrons that this idiot lost to form liquid magnesium. Are we okay, friends? Because it has to be hot enough to keep your ionic compound liquid, right? Means it's confirmed hot enough to keep your metal liquid. Questions? Well, I'm good. Hey, okay? Okay, So, this is just a simple practice, okay? We have a little bit more to go through. Just hang in there for a moment. Okay, I'm glad that we kind of got the hang of it over here. Okay, remember about who wins and who doesn't win and all this. Now let's talk about case study. Okay, this is one of the few notes that I will split in two. Okay, I'll split into half because frankly speaking, if I go through everything at one shot, it is like a info dump. Okay, you're not going to register anything at all. Okay, so when I talk about aqueous copper 2 sulfate, okay, this fella, once we see him, okay, he is your special scenario or special case. Okay, copper 2 sulfate has 2 special scenarios. Number 1 is copper 2 sulfate with inert electrode. Again, what's inert? Okay, inert means useless, unreactive. Your electrodes don't take part in the reaction. Okay, case in point, maybe something like graphite, something like platinum. Okay, all of these guys don't take part in the reaction one. Can? Okay, but I still aqueous copper 2 sulfate, right? So I still have Cu2 plus, I have H plus, I have sulfate, and I have OH minus. In our competition, okay, it is going to be these two against each other, right? Correct, Tetra? Michelle, who wins? Cu, agreed. Okay, he will win because less reactive. Remember, hydrogen wins almost everybody except for those who are less reactive than he is. Well, correct or not? Okay, then sulfate versus hydroxide. Dylan, who win? Hydroxide, because sulfate will never win. He's useless. Okay, this guy will win. So, in our equation, okay, who is going to go where? Let's label first. Positive terminal, negative terminal, positive electrode, negative electrode. Are you okay? Who's going to go towards positive electrode? Or your anions, aka hydroxide. So your reaction on the positive electrode is the same as what we've been doing so far. Okay? Okay, on the negative electrode, however, it is Cu2 plus now that will come here to undergo reduction. When your Cu2 plus undergoes reduction, you will gain electrons. And then you form pure copper metal. Which is why, as you can see, okay, on your papers, okay, you have solid copper coating, okay, on all around the side. Okay, it coats your copper metal. It coats your electrode. Correct or not? Right? Are you okay? Okay, so, okay, I hope I don't have to go and balance the equation out for you guys. If you want to, you can go ahead and do it. Okay, but questions that will come out based on this case study is, why is it, this person conduct the experiment, then he realized, the solution become more and more acidic. Okay, your pH probe, the pH slowly drop. Why? It's because he is getting used up. If your OH minus decreases, means your H plus eventually becomes more than OH minus, aka pH decrease. I hope you guys know what I mean. Okay, being acidic does not mean I have no hydroxide. Being acidic means I have less hydroxide than hydrogen. Okay, let me repeat that. Acidic means H plus more than OH minus. It does not mean that I have zero OH minus. No. Yes? Nope. Not acceptable as an answer. Okay? Next. Sulfuric acid will be what's left behind after everything is going on. After everything is done. Not at the start. Yeah, but who's to say that your H plus goes immediately to your SO4? I still have some hydroxide left behind as the reaction is progressing. It's only at the very end that you're left with H2SO4. Yeah lah, but you cannot say that sulfuric acid is formed. You can only say that there is an imbalance between H plus and OH minus. Are we okay? Good. Okay, what's another observation we will notice? Hey, what the hell? Your Cu2 plus, from your QA topic, from your QA knowledge, you know that he is blue. Right? So as your reaction progresses, your blue solution disappears. Because your Cu2 plus, who is the one that gives you the blue color, is gone. He slowly is removed from your solution because he gets reduced to form pure copper metal. Your blue color, okay, will start to fade. Understood the thing? Good? Okay? Dylan? Michelle? Kenna? Tetra? Okay, what's something else we will notice? Your Cu2 plus is indeed giving me copper metal, right? And copper metal is reddish brown or pink. We say pink metallic deposit or pink solid deposit because you get reduced to form pure copper metal. And the last observation is very easy. Okay, you are forming oxygen gas at the other side, so you have effervescence. That's all. Questions? No question? Are we okay? Well, I'm good. Kaylin? Question? No, Let's carry on. Okay, case study number 2. Okay, case study number 2. Copper 2 sulfate, but this time your electrodes are no longer useless, people. Your electrodes are made of copper itself. This is important. Okay, if your electrode itself is made of copper, he is not useless anymore. And if he is not useless anymore, he will take part in the reaction. Okay, let's take a look at this. Again, positive terminal, negative terminal, positive electrode, negative electrode. Okay, the only difference between this setup and the one before is now at your anode, okay, instead of OH minus winning, okay, OH minus now loses out. The metal himself undergoes oxidation. Your electrode is no longer useless, right? He is not inert anymore. So he will react. He will react to form his own ion. So I form Cu2 plus here. Okay, you keep forming Cu2 plus. As a result, your copper metal slowly becomes smaller and smaller and smaller. Can? Okay, every time you form, okay, it gets smaller and smaller. Understood? Well, good. Okay, at the same time, you are going to have your Cu2 plus, which will happily come over here to take electrons. Can? Okay, so what exactly is happening? The analogy I like to use for this one is, okay, imagine you are in a fucking football game or whatever. What you are going to do is you are going to pass the electrons to yourself. Over here, you lose the electron, right? Then the electron flow. Just nice, you come here and you take the electrons that you previously lost. Gets? Okay, you are passing the ball to yourself in this scenario. Okay? So, here you have Cu solid, okay, to form Cu2 plus, then your Cu2 plus will gain back the electrons you originally lost to form pure copper metal again. Are we okay? Good. So, observations wise, relatively simple. Okay, I already said this guy will get smaller because your solid is gone. Correct? Your solid is getting like eroded, so to speak. You, here. What did I say? What? Copper 2 is getting smaller. Your copper anode lah, okay, the anode himself is getting smaller because you're undergoing oxidation. At the same time, this guy is getting fatter because you are reducing here to form solid copper metal. Okay, cathode size is increasing. And last but not least, okay, because originally your Cu2 plus your blue solution will fade, right? The original scenario is your blue color disappears, because your Cu2 plus is getting used up. Agree? Now, even though my Cu2 plus is getting used up here, you are regenerating him on this side. So does your blue solution actually disappear this time? No. Your blue solution remains there. He remains blue. Okay? How we explain it is, your copper Cu2 plus that get discharged at cathode come from anode. Then keywords are no net loss of Cu2 plus. no net loss of CO2 plus, so the color and the concentration does not change. Yes. If you have to mention that whatever you use up there is replenished on the other side. Can. Yeah. Are we okay? How's this topic so far? Good? Not good? Huh? You got the... What's new, man? Okay, here's what's going to happen, guys. Okay, I will stop the lesson here today. Okay, but chill, okay, don't worry. Next week, I will extend a little bit. Okay, right? Okay, you're paying for 2 hours, I don't want to shortchange you all. So I should give you guys back the time. Okay, but next week's class, I will use this one and this one as a warm-up. Okay, so we kind of get back into the electrolysis thinking sort. Okay, then we start on some questions. Cool? Yes? Okay. Okay, if there's nothing else, then I will end the lesson here today.